All right, ready to dive into some logic.
Always.
Well, today we're looking at something called relevance logic
Oh, yeah, that's a fun one. It's this branch of non-classical logic.
that really makes you think differently about how we connect ideas.
Yeah, it challenges all those old school ideas of truth and implication.
So
Uh,
instead of just like true or false,
right, it digs into
it's about
sentiment.
whether the premises really back up the conclusion.
Yeah, in a way that actually, makes sense.
So it's not just enough to have a true conclusion.
Nope.
We need, like,
You need a connection,
a
right.
connection. It needs to be relevant.
Exactly. Relevance logic, you can't just toss random facts
It
together.
just be like, boom, logical argument.
Right, exactly. The way we, use implication in everyday language.
It just feels like there should be a stronger connection there.
Yeah, much stronger.
Can you give me an example where classical logic kind of messes this up?
Oh, absolutely. So you know how in classical logic,
Yeah,
a true statement will imply any other true statement?
yeah.
So you could say something like, okay, if the sky is blue, then 2 plus 2 equals 4.
Okay.
And technically that'd be totally valid.
But that's crazy. What does the color of the sky
No.
have to do with math?
It's a paradox, right? It's like one of those
Exactly.
head scratchers that shows you where classical logic kind of falls short.
So relying on truth values doesn't give you the whole picture
Nope.
of what if-then really means.
Exactly.
Okay,
Yeah.
so how did philosophers try to fix this?
That's where this beautiful thing comes in, relevance logic.
Okay,
Way back in the early 1900s, you had people like Hugh McCall.
okay.
They started questioning these weird implications.
Right.
They were like, there needs to be a stronger connection here.
Should make more sense.
Yeah, between the antecedent and the consequent.
So relevance logic is all about making sure the premises are really supporting the conclusion.
Yes,
Not just that it's true, but that it's actually relevant.
that's it. It's trying to create systems where those implications are super tight.
Okay.
If A, then B, you need a real relationship between A and B.
I can see why a philosopher would love this.
Right.
Relevance logic feels like how we actually argue
Totally, yeah.
and talk in philosophy.
Totally. And so one of their big principles, the variable sharing principles,
Okay.
it basically says for A implies B to be legit in relevance logic.
Okay.
A and B, they've got to share at least one propositional variable.
So if I'm arguing like the ethics of AI,
Right.
and I just bring up my favorite pizza topping,
That's a
problem.
red flag, yeah.
Okay.
It's like changing the subject, in a conversation.
Right.
This principle's a filter to make sure the ideas belong together.
Okay, that makes sense. But is sharing a variable enough?
That's a great question. It is necessary.
Okay.
It's necessary, but it's not always enough.
Oh, okay.
You can still have cases where just sharing a variable doesn't quite cut it.
Doesn't get to the nuances.
Exactly.
Okay, so what other tools did relevance logicians come up with?
Well, things get kind of tricky here. One of the big innovations, ternary relations semantics.
Ternary relations. Okay, hit me.
All right, so in modal logic, you usually have a binary relation, like
Okay.
accessibility between two worlds.
Yeah.
But relevance logic is like, nope, we need 3 worlds.
So instead of 2 points, we have 3 points making like a triangle.
Yeah, that's a good way to picture it.
Okay.
And now the truth condition for A implies B gets a lot more complicated.
Okay.
It involves how these 3 worlds connect, how the truth of A in one
Right.
relates to the truth of B in another, all mediated by this 3-place relation.
I'm trying to picture this in my head. I'm not sure I'm there yet.
It's a lot, yeah.
What's the key takeaway about relevance here?
Okay, so the crucial part is that this 3-world thing,
Yeah.
it guarantees the implication isn't just about A and B being true in their own little bubbles.
Okay.
There has to be a real connection between them.
Established through this relation.
Yes, exactly, for the implication to hold.
So it's about building a web of connection
Exactly, yeah.
instead of just checking if they're true or false.
Right, and then there are all these philosophical interpretations of this ternary relation.
Oh, tell me more about the interpretations.
So you've got philosophers like John Barwise and Greg Ristall. They see these worlds as information sites.
Okay.
And the relation, channels for information flow.
So the information has to be able to actually flow.
Exactly, and implications relevant if the information in one world can actually get to another.
And support the consequent? Okay, that's cool.
And then you have Edwin Rares, who sees them as situations.
Okay.
The relations about how information in 2 situations, leads to inferences about a third.
So it's like having clues in 2 different spots
Yeah,
that when you put them together.
they tell you about a third.
Yeah, okay.
It highlights how relevance logic goes beyond single statements.
Okay.
It's about seeing how information can combine to make new conclusions.
This is so interesting, but I am curious about negation.
Ah,
In
yes.
relevance logic,
Right.
does it work the same way as in classical logic?
That's where things get like even more interesting.
Okay.
Because relevant logic, it has to think about worlds,
Okay.
where statements might be true and false.
Or neither.
Or neither, yeah. Non-violent worlds.
So we're not in a binary anymore.
No, no,
Here's a
no.
spectrum.
Yeah, a whole spectrum of possibilities. And so to handle negation in these like funky worlds,
Okay.
Richard and Val Ratley came up with something called the star operator.
The star operator. Okay. I'm intrigued. What's that?
All right, so picture this. You have a world, we'll call it A, right?
Okay.
The star operator makes a mirror image of that world called A.
Okay.
A statement is false in A if and only if it's true in that A world.
So, like a parallel universe where everything's flipped.
Exactly. It's a really cool way to think about negation, especially when things aren't so black and white.
Yeah. Yeah. In these weirder worlds. Okay.
But there are other ways to do it, too.
Oh, there are.
Yeah, like Dunn's four-valued semantics,
Okay.
where you can have more than just true and false.
I'm starting to see how relevance logic really changes how we think about logic itself.
Yeah, for sure.
It's not just tweaking a few rules, it's a whole different perspective.
It's a fundamental shift, and that's what's so exciting about it. And actually, this exploration of negation, it takes us to another super interesting aspect of relevance logic, its ability to handle, get this, naive set theory without any contradictions.
Naive set theory. Doesn't sound so safe.
It's a wild ride. So in classical set theory, you have this idea called the naive comprehension axiom.
Okay.
It basically says, for any description, you can make a set.
Okay.
Of all the objects that fit that description.
Okay.
But this leads to some famous paradoxes, like Russell's paradox.
Oh, yeah. That was a classic.
Which can really mess things up for set theory.
It's like the set of all sets that don't contain themselves.
Exactly. It creates this big contradiction. But certain weaker relevance logics, they can handle this axiom without falling apart.
So these weaker relevance logics, they're a bit more restricted.
Right.
They avoid those set theoretic explosions.
You got it. They put limitations on things like the contraction principle,
Okay.
which lets you use a premise multiple times in an argument.
So it's like you can only use a piece of evidence a certain number of times.
Yeah, like in a debate or something.
Okay.
And by limiting certain rules, they can keep things consistent
Right.
while still working with that naive comprehension axiom. One of the pioneers in this was Ross Brady.
That's pretty amazing. So are there systems that aren't mainstream relevance logic,
Yeah.
but still share that idea of making inferences relevant?
Oh, definitely. There are a bunch of systems that don't fit neatly into that relevance logic box.
Oh.
But they're still wrestling with those ideas of relevance and logical consequence.
Who are some of these rule breakers?
Well, you've got Graham Priest's logic. It's called N4.
Okay.
It's cool because it uses a four-valued semantics,
Okay.
kind of like Dunn's system.
Right.
And it has these normal worlds and non-normal worlds.
Oh, we talked about those non-normal worlds before, right?
Yeah, the weird ones.
Where things get strained.
Exactly. In N4, the truth values for implications in those non-normal worlds,
Okay.
they're like totally random.
Okay.
But in the normal worlds, an implication A implies B is only true.
Okay.
If B is true in every world where A is true.
So there's like a stricter standard for normal worlds.
Yeah, you could say that.
And anything goes in the non-normal worlds.
Pretty much. And this lets N4 keep that focus on relevance
Okay.
while still being a bit weaker in what it can prove.
Okay, so it values relevance, but doesn't have all the power of the bigger systems.
Right? Then there's Neil Tennett's core logic. It comes at relevance differently.
Okay.
So one of those classic fallacies relevance logic tries to avoid is ex falso quodlibet, sometimes called explosion.
Yeah, the idea that from a contradiction you can conclude anything.
Exactly. Like if something is both true and false, then every statement is true.
Right, that seems a bit off.
So most relevance logics, they'll get rid of this rule called disjunctive syllogism
Okay.
to block that explosion. But core logic actually keeps disjunctive syllogism.
Oh, okay.
And it keeps other standard rules from intuitionist logic, too.
So it's not rejecting specific rules.
Right. Instead, it puts limits on the transitivity of logical consequence.
Okay.
That's a really fundamental idea about how inferences can be linked together.
So it's like you have the building blocks of inference, but you can't just extend them forever.
Exactly. It's a careful balancing act. And then we have William Harry's logic of analytic implication.
Okay.
It takes that variable sharing thing we talked about to the extreme. In this system, for A implies B to work.
Okay.
All the variables in B have to be in A, too.
That sounds pretty strict.
It is, and that means other principles like disjunction, introduction, and contraposition,
Okay.
those have to be limited, too.
Okay.
But this super strong version of variable sharing, it tries to get at a very specific kind of relevance
Okay.
where the consequent is, in a way, already present in the antecedent.
So it's like the consequent is a seed already there in the antecedent.
Yeah, I like that. And this system has a really neat possible world semantics developed by Kit Fine
Okay.
that adds this idea of subject matters to the model.
So not just worlds, but what those worlds are about.
You got it. An implication works in the system if it's true in different worlds.
Okay.
And every subject matter of the consequent is also a subject matter of the antecedent.
So it's about staying on topic.
Exactly. It's a really cool way to show how relevant implications need to stick to the subject.
I'm really starting to see how much variety there is in relevance logic.
Yeah, for sure.
It's not just about avoiding paradoxes. It's about exploring how implication and logical consequence really work.
Exactly. And this journey through all these different systems, it leads us to another exciting thing about relevance logic. Its uses outside of pure logic.
Oh? How so?
Well, one area is deontic logic.
Okay.
That's the logic of things like obligation and permission.
So like the logic of ought and should.
Yes, exactly. And traditional deontic logics, they run into this problem called the fallacy of derived obligation.
Okay.
It's basically saying that if something's logically true, then it must be obligatory.
That sounds odd.
Right, it's like, why should it be obligatory for 2 plus 2 to equal 4?
Or for the sky to be blue.
Exactly. Those are just facts, not moral obligations.
So how does relevance logic help with this?
Well, relevance-based deontic logics, they use those non-normal worlds
Okay.
where not every logical truth has to hold.
Okay.
So they can have systems where obligations come from relevant reasons.
Right.
Not just because something's logically necessary.
So it's not because it's true you ought to do it, but more like because of these reasons you ought to do it.
Exactly. And there are other applications too. J. Michael Dunn, he came up with a theory of intrinsic and essential properties
Okay.
based on relevant logic.
Those are some big philosophical concepts. How does relevance logic fit in?
Well, in his theory, which he calls relevant predication, an intrinsic property is one that's relevantly implied by the object's identity.
Okay.
So, like, being a triangle intrinsically implies having 3 sides.
It's not just that it happens to have 3 sides, but it has to have 3 sides to be a triangle.
Exactly. And this approach gets around some of the problems other theories have.
This is incredible. So relevance logic is popping up in all sorts of areas.
It is. We also have relevance-based theories of counterfactuals, epistemic logic,
Okay.
even applications in computer science, like linear logic, which is about resources.
Okay.
It borrows from relevance logic.
Wait, resources. So like how we use time and energy.
Yes. Linear logic, it rejects the contraction principle, just like relevance logic.
Okay.
And it's used to model how we use resources, where you can't just make infinite copies.
This is amazing. Relevance logic is changing how we understand logic itself
Yeah.
and philosophical and even practical problems.
It really is, and this is just scratching the surface. There's so much more to relevance logic.
It does feel like we've fallen down a rabbit hole, and I'm not complaining.
That's the fun of logic and philosophy in general, always questioning, challenging assumptions, trying to understand more.
I'm seeing how this whole relevance logic thing, it goes way beyond just like the formal logic stuff.
It does, yeah.
It makes you think about how we argue,
Yeah,
how we connect evidence and conclusions,
right.
even how we think about truth.
It's a big shift in thinking, and that's what makes relevance logic so fascinating. It's
Yeah.
not just symbols and systems.
Right.
It gets at what it really means for ideas to be connected.
As we wrap up this exploration, is there like a final thought you want to leave our listener with?
Ooh, okay.
Something they can ponder as they go back out into the world
Right.
now with this new understanding of relevance.
Let me see. Okay, here's a question for you. Think about all the arguments you see every day, in politics, philosophy, even just conversations.
Yeah.
How would those arguments change if we used relevance logic?
Ooh, that's a good question.
Would they be more focused,
Yeah,
more insightful, maybe even more persuasive?
right?
Or would they fall apart because they're full of irrelevant stuff?
It makes you really look at not just what's being said,
Yeah,
but how it all fitting together.
exactly.
Maybe relevance logic is the key to better conversations everywhere.
It could be, yeah. It's definitely a powerful tool for thinking critically.
Yeah.
And as we finish up this deep dive, I want to say, the world of logic, it's huge.
Right.
Relevance logic is just one path.
One way of looking at it.
There are so many other logical systems out there,
Yeah.
each with its own rules and insights.
It sounds like there's a whole lot more to explore.
Definitely.
I can't wait to see where we go next.
Me too.
But until then, keep thinking and keep those arguments relevant.